is the second part of calculus. We have talked about the differential calculus. Now we are moving to integral calculus, which is always the inverse of differentiation. In integration, the simple layman definition we can give to it is like addition. When we are dealing with differentiation, we say we have to differentiate by subtracting the power. But in this case, we integrate by adding the power, and we are going to express that in mathematics notation. Now, we are told that if d ds, we have a function which is s is to the power 4. When you differentiate this function using the normal power rule, the 4 will be taken down. That is, the 4 will be multiplied with the coefficients here, which is 1. Then you reduce the power. That is differentiation. Now, we are dealing with integration. Integration is also divided into two types. We have the indefinite integral. Then later on, we are going to be dealing with what? Definite integral. In indefinite integral, the limit is not included. In indefinite integral, there is what we call limit of integration, which we will explain later. This is an integration. This elongated s is called what? The integral. The integral, and this one that we have there, this function we are integrating with respect to s, is what? Integrand. Integrand. The integral, which is the elongated s, and this integrand, which are the function you are integrating with respect to s. Now, when you want to integrate this using the power rule here, then we have 4 is a constant. You can bring it outside. 4 is a constant. Return the elongated s is to the power 3, the s. Then that is the same thing as 4 is a constant. Using the rule here, this one is a power rule. Then this one will be what? 3 plus 1, the opposite of differentiation. So I'm adding here. Then this 3 plus 1, which I've added, instead of you to multiply, as in the case of differentiation, you multiply the power. After you must have deducted it, you multiply the power. But what we do here is what? Bring down the power, you divide the power. Then this gives, at the end of the day, 4 s is to the power 3 all over what? All over 4, which is the same thing as what? S is to the power 3. So what you observe in this is that this one will give us s is to the power 3, which was the original function, which was s is to the power 4, sorry. This one is s is to the power 4, and this is also s is to the power 4, sorry. So this is s is to the power 4. After you have integrated, you put 1 inside that function, and that gives us the original function. When I integrated, when I differentiated, I get 4 s is to the power 3. Then to get back the function, that means you integrate this derivative, and you get back s is to the power 4. Moving on. The general perception is that if you are differentiating a function using the power law, we have n s is to the power n minus 1. That was what we were told when we were differentiating. But when you are integrating, generally, a function of x, then is going to be n, is going to be s is to the power n plus 1. You had, in this case, we subtract the power. In this case, we add the power. Then the power will multiply here, but the power will be brought down, will be divided here. Provided that the n, the power that you have there, the n is not minus 1. If the power you are giving here is minus 1, let me say you are giving s is to the power minus 1, then you will not be using this procedure. Provided n is not minus 1, n can be minus 2, it can be minus 3, but it must not be minus 1. If it is not minus 1, because if it is minus 1, this denominator is going to be minus 1 plus 1, which is 0. This is minus 1 plus 1. This one will be undefined mathematically. So the power here, the power on n, on any function of s you are giving, must not initially be minus 1. That's the only exception to this rule. Any integration, any integrand you are looking for, you add 1 to the power, then you bring that power you have added 1 to, you bring it down. Now let's continue with the explanation. These are trigonometric function. We know that when you differentiate sine, you are expected to get cos x. Now, for me now to get sine s back, that means you integrate the derivative, and the derivative is cos s. When you integrate cos s, then you are going to get sine s. You observe that we are not putting minus sine s here, because this is an even function. So when you integrate an even function, which is addition, then you get sine x. When you differentiate cos s, we are expected to get minus sine x. But if I'm differentiating sine s, which is the derivative here, then you have to get, this one is an odd function, then you have minus cos x. This one is the x, this one is the x. Moving on, let's approach this. Let's approach what we are dealing with here. This one can be rewritten as any constant can be brought outside. This is 7 integral 1 over 2s minus 5 dx, and this one can be equal to 7. You are integrating 2x minus 5 raised to the power minus 1 dx. So the power of this is minus 1. You are not to integrate using the power rule that we expressed here. You are not to integrate because the power of this n, your n is minus 1. So you will not be adding 1 and bringing it down. That will be wrong. So anytime the power of n, which is n, is minus 1, then you just take the ln of 2s, ln of that function. Anytime the power is minus 1 here, just take the ln. This ln is Neperian log, which is expressed also as this 7 log 2s minus 5 base e. So log base e is what we call ln. That's the same expression. Now moving on, we have the integration of polynomial. We are integrating polynomial. This is a polynomial that we have to integrate. It's more or less like when we are dealing with differentiation of polynomial. So you are integrating each of them. This one can be rewritten as an integration of 4s cubed dx plus integration of 5x squared dx minus integration of 2s dx plus integration of 7 dx. That means you are integrating each of them one after the other. So integrating, you can bring the constant out, s cubed dx, bring the constant out, integral s squared dx, bring the constant out, s dx plus 7 integral dx. So you are integrating only the function of s. This s raised to the power what? 3 plus 1, that is 4, all over 4, plus 5. When you integrate this, you have s is to the power 3, all over 3, minus 2. Integrate s is to the power 2, all over 2, plus 7. Integrate, this one is like you are integrating a constant, and this constant is like s is to the power 0. That's going to give us 1 because 1 is a constant. S is to the power 0 plus 1 all over 0 plus 1. That's the meaning of this. Now, this integral that we have been dealing with since morning is supposed to be an indefinite integral. And in an indefinite integral, we are supposed to be having the constant of integration after you have integrated. The constant of integration after you have integrated, and this one is called constants of integration. You have to add it if you are dealing with what? An indefinite integral. The constant of integration is needed. Going back to our work, then we must have our c, which represent constant of integration. This one too must have our c, which represent constant of integration. So we continue with our work. This cancel this. Then we have s raised to the power 4 plus 5 over 3 s cubed. This cancel this, minus s squared plus this one we got 7x plus the constant of integration. No further simplification can be done to this. Then finally, we have this indefinite integral using the same approach up here. Then this is 8 s is to the power 4, increasing this one with 1 all over 4 minus 3 s is to the power 3 all over 3 plus 4 s is to the power 2 all over 2 minus 5s plus the constant of integration. Cancel this. Then we have 2 s is to the power 4 minus s is to the power 3 plus 2 s squared minus 5s plus the constant of integration. And that will be all. Then we have to what? We have to give it a pause here. Yeah. So in continuation, we are dealing with integration by substitution. Given this type of integral, to find their value, we have to find the integral between the limit of 1 and 2. We have explained what we call indefinite integral before. Now we are dealing with what we call definite integral. This integral is definite because it is between the lower limit and the upper limit. The lower limit is this one below, which is 1, and the upper limit is this one below, which is 2. this one will give us a value, unlike the one we dealt with before. Now, we want to find this integration. Let's look at the value of this integral. Integral 1 to 3x plus 2 raised to the power 4 dx. We follow the same procedure. What's the procedure? We first integrate. This one can be expressed as integral 3x plus 2 raised to the power 4 dx. Then the limit can be put outside, which is 1 and 2. Then that means we deal with this the normal way we have discussed, the power. Now, this one is like we are integrating 3x plus 2 raised to the power 4 dx. And this one is like we are expected to integrate twice, just like the function of a function. Yes, we have the power outside and we have the inner function. When you look at it very well, that's what happens. We have explained that under differentiation. So, the integration of this kind will be applied or will be approached using what we call the substitution. As we are going to change the variable. The variable we are integrating in before was x. So we are going to change the variable by making the substitution of u is equals to 3s plus 2. We have dealt with this also. Then this is my u. Then the whole function here can be written as integral u raised to the power 4 dx. You know that this dx, we can actually say, we can get our du, then du is going to be what? 3 dx. Then I have to substitute this dx by saying my dx is equals to 1 over 3 du. Then putting that in here, then we have integral u 4 dx, that's equals to integral u raised to the power 4 dx is what? 1 over 3 du. Then in continuation, the constants, anytime you are integrating, constants should be separated. 1 over 3 can be brought outside, u raised to the power 4 du. So integrating this one normally, this one is u raised to the power 5 all over 5. 1 over 3 still stands. Then this one will be equals to 1 over 3 u raised to the power 4. U raised to the power 5 all over 5. Don't forget, it has limits, and the limit is what? From 1 to 2. So applying the limit, then we have 1 over 3 u raised to the power what? When you're applying the limit, you apply the upper bound first. Anyway, the limit is used for the u separately. So we have this 2 raised to the power what? Before we apply the limit, let's substitute for our u. The u is a variable, and u is equal to what? 2s minus 3. So 3s plus 2. Before we apply the limit, this is raised to the power 5 all over what? All over 5. Then we have 1 and 2. Then we can continue with that. You can bring your 5 out by saying this is 1 over what? 15. Then this 3s plus 2 raised to the power 5 all over what? All over 2 and 1. So applying our limits now, anytime you are applying limit, you start from the upper limit. The upper limit will be what? 3.